All right, today what we're going to be talking about is trig problem applications. So doing mainly word problems. For your homework, you only have 2 word problems, but then there's other kind of word problem-like questions on there as well. But today, before we get started, we should probably talk about 2 key vocabulary terms, which is the angle of elevation and the angle of depression. Okay. Because these will often come up with word problems. And in fact, I think there is one question on your homework that does deal with this as well. So there is these 2 angles in a lot of real life scenarios called the angle of depression, the angle of elevation, which is really important when discussing a lot of like flying problems and a lot of different problems with I think there's one with the shadow question on there as well. And what these are is the angle of depression is the angle formed by a horizon line or a horizontal line and the line of sight to an object below the horizontal line, and vice versa. The angle of elevation is the angle formed by a horizon line and the line of sight to an object above the horizontal line or horizon line. Okay. And like I said, today what we're going to be talking about is we're going to be talking about solving word problems. And so we're going to really be having 2 main types of word problems. One is when we are going to be using the law of sines, and one that we're not. We're just going to use normal trig functions like how we would use sine, cosine, and tangent in the past. And so that's really my biggest tip is one, determine if you're going to use the law of sines. And if you don't have a right triangle, then you know you're going to use the law of sines, because I can't use sine, cosine, and tangent on their own with on non-right triangles. So if we have a non-right triangle, then we know we're probably going to have to use the law of sines. Okay. But before we do that, what I want us to do is talk about and identify these 4 angles here. And it says classify each as an angle of elevation or the angle of depression. So I want you to take a few moments and see if you can tell me, are these angles of elevation or angles of depression? Okay, pause the video if you haven't done so already to solve this. All right, looking at this, let's start with angle 1. And what we can say is, well, I have this horizon line or this horizontal line right here. And the line of sight, an object in the line of sight is this object right here, is this person. This person up here at the restaurant is looking at the person on the observation deck. And so if you look at this angle right here is below the horizon line. Thus, this is an angle of, I'm just going to say AOD for angle of depression, and then AOE for angle of elevation. So because this is below the horizon line, this is an angle of depression. Okay. Whereas vice versa, angle 2 is looking at it in retrospect to the person on the observation deck with this horizon line right here. And the person on the horizon deck is looking up at the person at the restaurant. And this person is looking up. This angle is above the horizon line, which must mean this is an angle of elevation. This is an angle of elevation here. Okay. And very similarly, because the person on the observation deck is looking down at the person that is on the ground, this angle here with the horizon line being again the one on the observation deck, because this angle E is, because they're looking down, because this angle E is below the horizon line, this would be an angle of depression. And similarly, angle 4, this person on the ground is looking up at the person at the observation deck, and that therefore must mean that the person on the ground has an angle of elevation. Okay. So it's depression, elevation, depression, elevation. Okay. Let me know if you have any questions, and I can get back to you as soon as possible. But we're going to move on to kind of our first word problem at this point. Okay. And so let me move this. And this first word problem deals with these bungee cords. Okay. So Reagan is on this bungee ride, and he stands halfway between two vertical posts. Okay. Two bungee cords extend from the top of the post, so top of this post, to Reagan's waist at a height 1 meter above the ground. How tall are the vertical posts? Well, let's think about this. Let's look at this. And what we are able to do is we can actually redraw both of these triangles. If we look at this, I have one triangle that is x meters tall, goes over to Reagan's waist, and this line segment I'm about to draw is the bungee to Reagan's waist. Oops. So I got to redraw that. That was maybe I should just use the line feature here. Starts at the very top and goes to Reagan's waist. Okay. And so looking at this, if I were to redraw this, well, we know that this is 70 degrees. That's what was given to us in the picture. This is 70 degrees. We know that this post is what we're trying to find. That was what we said was X, and we can see that in our picture right here. And so the problem becomes, well, what else do we know at this point? Well, if we read this question again, it says that Reagan stands halfway between the two vertical posts. Well, if between the two vertical posts is 8, well, if this is right here, if this is on our picture where Reagan is standing, then this length must be 4 meters long. This must be 4 meters long. And so if you look at this, like I said, if we had a non-right triangle, we would probably use the law of sines. Well, if I look at this, the post is standing perpendicular to the ground. So meaning we are dealing with a right triangle, which means at this point, I can use one of our trig functions. Well, which one are we going to use in respect to 70? Ask yourself, am I going to use sine, cosine, or tangent? Well, looking at this, I am going to use tangent. I have the opposite side and I have the adjacent leg. Okay, I'm going to use tangent. So the tangent of 70 is equal to the opposite x over the adjacent side 4. Okay, over the adjacent side 4. And so what I can do to both sides is I can multiply both sides by 4. If I do that, that will leave me with x on the right-hand side. And so the value for x is equal to 4 times the tangent of 70. And if I were to put this in my calculator, what we'll find out is tangent of 70 is 2.747. And then now multiply this by 4. That means x is equal to 10.99 meters tall. So almost 11 meters tall. Okay, so if we look at this, this is 10.99 meters tall, and we have answered what the question is asking of us. Okay. Now, if you have time, if you have still things to write on this slide, please take some time, hit pause, and go from there. But again, because this was a right triangle, we were able to use one of our sine, cosine, and tangent functions. Okay, but moving on to the next question. Here I say, okay, an instructor holds a safety rope at point C. So at point C right here, the instructor is holding the safety rope for a student to rappel from the anchor point T. The rope between them currently measures 61 feet. And we can see that here, that is C to T. That is 61 feet here. How much more rope should the instructor let out so the student can make it to a resting point at point R. So right here. So in other words, what we're really trying to find is we're trying to figure out how much more ropes the instructor let out to reach point R. In other words, we're trying to figure out the length. If it'll let me highlight, we're trying to figure out the length of this segment right here. This would be CR. We're trying to find the length of CR. Okay, because in theory, that's where this student should be at, is at R, and that should be represent the rope for when the student's at R. Okay, and so let's redraw this triangle here. I have TR, and then I have CR, and then I have, oh my gosh, if this is like not the worst triangle I've ever drawn, including the ones in class, I don't know what is. Let me use this here. Okay, so we have TR here, and then we have this angle right there, and we can draw one more angle, or one more side right here. Okay, so taking a look at this, I have this really small triangle, but what I know is actually a lot of pieces of information about this really small triangle. I know, well, this is C, this is T, and this is R. And so one of the things I know is that C to T is 61 feet. That is what they gave us. They also said that we're going to name this X degrees. And they're going to name this right here Y degrees. We're going to name this Y degrees. Okay. Now, taking a look at this, I can notice one thing. I can notice that if I look at the big triangle, it says that this angle right here is 75, but the entire angle is 79. Well, that must mean then that y is the remaining part of the 79 in comparison with the 75, which must mean y is 4 degrees. This is going to be 4 degrees. Okay. That is going to be 4 degrees. Okay. Well, another thing I do know is I can also figure out the angle for angle T up here. And the reason for that is if angle C in the triangle CTH, if angle C here is 79 degrees, angle H is 90 degrees, that must mean angle T in the big triangle. So if I actually were to draw the big triangle here, this is 90 degrees. Through this angle right here, that says that this right here is 79. Well, then that means that only makes the remaining angle here at angle T 11 degrees. So this right here is 11 degrees. Okay. And now at this point, that must gives us angle R for X. Angle R is 165 degrees because all three angles must add up to 180. 4 plus 11 is 15. 180 minus 15 is 165. And at this point, now I'm dealing with a non-right triangle to find CR, but I can find CR pretty easily using the law of sines. Okay. And at this point, I'm actually going to erase this pink triangle here. So if you haven't written it down, make sure you do that so I have room to actually do the problem. Okay. But taking a look at this then, I can use the law of sines and say the sine of 165. And if you forgot, it should be the sine of 165 over the opposite side of that angle. Well, the opposite side of angle R is CT. That's 61. That should be equal to, the sine of, well, we're looking for CR. What is the angle across from CR? Well, that is angle T. So this would be the sine of 11 over X. And I'm going to fix this 61 because it does not look like a 61. It looks like it looks like LOL. But at this point, now I can solve by cross multiplying. Okay. And say the sine of 165 times by x is equal to the sine of 11 times by 61. And I'm kind of getting into our picture, so I apologize. Times by 61. Okay. And at this point, what we would do is we would solve for x. Okay, at this point, we would solve for x. So what I want you to do is hit pause on this and see if you can figure out the value for x. Okay, so hit pause, try this question on your own, and solve for x. All right, so answering this question, well, the sine of 11 is 0.19. So the sine of 11 is 0.19. And I'm going to multiply this by 61. So let me do that. Multiply by 61. And so what I get here is the sine of 165. The sine of 165 times by x should be equal to 11.63. 11 point, actually I'm going to say 11.64. Okay. And what I'm going to do now is to be able to solve this is I'm going to divide 11.64 by the sine of 165 because my goal is to find x. Well, but dividing by the sine of 165 cancels that out because again, the sine of 165 is just some number, so I can divide by some number. And what I get here is if I divide this by 160, sine of 165, I get x to be equal to 44. Well, about 40, I would say about 45. And so the question becomes, how much rope does she need, so the instructor need to let up in order for the student to make it to angle R? And to do this, what I have to do is, well, right now they have 61, and I need them to have 45. So how much does the instructor need to take? Well, the instructor needs to take, it's about 16 feet of rope. Okay, about 16 feet of rope at that point. Okay. All right. Again, take a pause on this video. Let me know if you have any questions, and then we will go from there. All right, so I'm going to move on. Hopefully everyone had this copied down into their notes, but I'm going to move on. Clear this drawing. And I'm going to answer our last question that we have for today, which deals with how can we use trigonometry to find the area of the triangle ABC? Well, if we think about this, if we go back to what we have learned in the past, the area of a triangle, it should be equal to 1/2 times the base times the height. Well, right now I don't have the height. I do have the base, which is actually conveniently b, so I don't have to change this here. I have the base b. And how we can find the height? Well, we already know the height of any triangle is going from one vertex is really the altitude. It goes from one vertex and goes perpendicular to the opposite side because that is the shortest distance away from B to the opposite side. Okay. So I'm going to say that this is the height right here. Okay. Well, one way we could solve this is think about the trig functions we've had in the past. I can say at this point that if I want to look in respect to C, I'm going to say respect of C. I want to figure out I want to figure out how I can get the hypotenuse in respect to angle C. Well, angle C is, well, H is the opposite. So I can use either sine or tangent here. I'm going to use sine just to make things a little bit easier. And I can say that the sine of C is equal to the height divided by A. Okay. And I can solve for the height by multiplying both sides by A. And so let's do that. Let's multiply both sides by A, and we can solve for the height and multiply both sides by A. And we can get the height to be equal to A. Whoops, that's a terrible A. I don't know how I got that badly. A sine of C. And so the area of this triangle, and for all triangles that we have here, the area of a triangle is 1/2 times by the base, which is going to be B in this case, times by A, because it says equal to the height, times by the height. But again, the height is A sine of C, A sine of C. And another way we could have thought about this is if I wanted to do it in reference of angle A, I could have said that the sine of A, now the sine of A is the opposite in this right triangle, which is H over C. That's the hypotenuse. C would be the hypotenuse. And in this case, I would multiply both sides by C to solve for the height. Multiply both sides by C. And the height in this case would be C sine of A. And so another equation I could have used here is the area is equal to 1/2 times by the base times by the height. But again, the height here is C sine of A, C sine of A. Okay. That is another example of another equation we could have had with the height. Okay. And arbitrarily, this actually gives us a third area statement. And what we can notice here is I did this, I made the altitude at B, but if I would have made the altitude at A and went to the other side to find the height of the triangle, that still would have worked. And what we can notice is we would have had this third area equation. And what we can see here is this area, or so yeah, this area is really equal to B times C. Just choose any two of the sides of the triangle and do the sine of the side that you don't include. So in this case, I chose sides B and C, so I want the sine of A. In this case, I choose sides B and A, so I need to use the sine of C. So the last one says that another area formula, and I need to do this in red so you can actually see it, another area formula is equal to 1/2 times, well, I have sine of A, sine of C, so at the end I want to have the sine of B. And so I have to choose the two sides that don't include this angle, so don't include B. It's going to be AC. Okay, so we have A, B, C. Here we have A, B, C. We have A, B, C. And these are our three area formulas, whatever one you'd like to use at any given moment. And this might be helpful for some questions in the homework, or I might ask you this on your quiz, your final quiz, not the one that's next, not the one that's on Wednesday. Okay, but this is it for today. Let me know if you have any questions, and I'll get back to you as soon as I can. Thanks, and have a good rest of your day.